All right, Algebra 1, good morning, afternoon, evening, whenever you guys are watching this here. So we are jumping into Section 3, Chapter 3. All right, so 3.3, titled Multi-Step Equations. And let's get the page number down here. Everybody have your textbooks open to page 139. All right, there we go. So I'm going to break down the steps that you guys have to take to solve a multi-step equation. All right, so for the most part, you can always use these same steps in this order, and you guys should be just fine in solving any problems that you get on tonight's homework. Okay, so the first thing is if you have the distributive property, you have to use that. Okay, so that's step one. If you see a set of parentheses and you see a number directly connected to those parentheses, then use the distributive property first. All right, step two, combine like terms. All right, so in other words, we're talking about variables, like if you see x and then there's another x, you're going to be combining those. And don't forget, if you have x plus x, that is 2x, and that is not x squared. All right, don't make that mistake. Also, combine the constant values. So that would be numbers that don't have a variable. Like if you see a -4 plus 5, combine those. There's no variable there. All right. The next thing is to add or subtract. So now you're going to notice we're going to get into very similar steps into previous sections that we had in Chapter 3. So add or subtract as your next step. And by the way, when you add or subtract, that's going to be with the constant value again. And then step 4 is either multiply or divide by the coefficient. All right, that final step is to isolate the variable and get it to like x equals and then just a number right there. Okay, so those will work every time. There is a little, like an asterisk, if you will, that I'm going to put, but it's further down into the notes, and you'll understand what I mean by that really soon here. Okay, right there, to eliminate a fraction, now this is kind of a random one here, but to eliminate a fraction, if you have that fraction connected to a set of parentheses, you want to get that fraction to disappear. Okay, so how do you do that? You're going to multiply both sides of the equation by the reciprocal of that fraction. Okay, so multiply both sides of the equation by the reciprocal of that fraction. You're going to see an example problem that I do of this, so pay close attention to that, and make sure that you notice that once you multiply by the reciprocal, the fraction will disappear, but you do have to do it on both sides. Okay, so you can't just multiply by the reciprocal on one side. What you do to one, you have to do to the other. Okay, so that covers everything there. Let's get into our example problems. All right. Okay, so step 1, do you see anything needing the distributive property? No. So then jump into step 2, combine like terms. All right, and we have like terms that are right here. Okay, 9x minus 2x. They share the same variable. So treat this as 9 minus 2, giving you 7x plus 4 equals 32. And guys, now we're doing the exact same style of problem that we just did in the previous section. So the second, or now third step, is add or subtract. We will be subtracting from both sides to get rid of that 4 right there. So we have 7x equals 28. And then final step, to isolate the variable, you will be dividing in this one. Both sides here by 7. Dividing by that 7 right there will isolate the variable. So x is now by itself. And you just have 28 divided by 7 giving you 4. Okay, so that covers the first style that you will have on your homework. Let's take a look at the next one. Okay, do we have the distributive property? Yes, we do. So let's do that. Distribute the 3 into both parts of the parentheses there. So I'm now going to have 2x plus 3x plus 12 equals 27. All right, next step, in our solving would be combine like terms right here. 2x plus 3x giving us 5x plus 12 equals 27. All right? And then again, just go through the normal steps in the previous section. Add or subtract. We will be subtracting 12 from both sides. All right? So now we're left with 5x equals 15. And then isolate the variable. So what do we do here? Divide both sides by 5. Okay, so 5 goes away, isolating the x, and x equals 3. Okay. All right, good. Let's move into example problem number 3. Make sure, guys, you can always pause the video, rewind the video. If I go too quick, that's the benefit of a video. Go back, pause it, rewind it. You're in control. Okay, here we go. Example problem number 3. Do you see the distributive property? Yes, I do. And in fact, I see it twice here. We're going to take the 4 and distribute right there. And they don't write it, but there is a 1 here. And why is that important? Because of that negative sign that's out in front of the 1, that when you distribute into the parentheses, will change the sign on both of those values. Okay, so let's see how that looks. First, do the 4, giving you 12x minus 4. Now, -1 times x would give you a negative x, and -1 times positive 5 would give you a -5. All right, so that's using the distributive property twice. Now, combine like terms. Look for the terms that go together. These guys right here go together, and then these two right here would go together. Okay, so variables, then constant values. All right, so 12x minus x giving us 11x, a -4 and a -5. Pay attention to your signs. That's vital there. Minus 9 is what that would give you, equals 24. Okay, and let's double check. All right, so in this, we are now, again, adding or subtracting. Just like we've done in the past, we now are adding 9 to both sides. That will cross out. That will cross out. 11x goes over. 24 plus 9. Let's see, 33. Okay. And then final step here, isolate the variable. Divide both sides by 11. Okay, don't forget, why do we divide? Because the problem is giving us multiplication. Do the opposite, divide. All right, 11's cross out, isolating the x. 33 divided by 11, 3 is our final answer there. Okay. All right, perfect. Let's do our last example problem. Here is one with a fraction. All right, so this would be the example problem that connects to the last note that we had up at the top of the page there. So let's multiply both sides by the reciprocal, okay? What is the reciprocal of -4/5? It is -5/4, okay? Or 5/-4. I don't want you to get confused with that negative sign. You just have to keep the negative in there and then flip the fraction, okay? So let's do that. Multiply both sides by the reciprocal. I'm just going to go ahead and keep that negative sign with the 4. Let's be consistent. Okay, and on that side, I'm going to put 28/1 so that you can see you multiply straight across. All right, on the left side, though, multiplying by the reciprocal crosses that fraction completely out. That's the purpose of multiplying by the reciprocal, is to get rid of it on that side. Now let's see what it does to the right-hand side. All right, 28 times 5 Let's see, that is 140. Negative 4 times 1 is negative 4. So that 140 over negative 4 is going to reduce to, let's see, 35? Yeah, okay. But negative, so a negative 35. So that's what this guy will make. Now let's rewrite what we have, okay? Because all we have on the left-hand side is 4x minus 1 because we eliminated the variable, or sorry, the fraction. We eliminated the fraction. Now we got to start to isolate, okay? What do we do here? Add or subtract? Add 1. Add 1. So that goes away. You now have 4x equals a negative 34. Okay, and let's make sure everything working out here. All right, we'll double check. Okay, divide by 4 on both sides. All right, and negative 34 over 4, giving us 8.5, or a negative 8.5. Okay, right there, guys. So let's take a look here at all the steps that we went through to solve this problem. Okay, so what we were given at the beginning here, we had a negative 4 over 5, parentheses 4x minus 1 equals 28. Good. Okay, flip it and double check that we multiply by the reciprocal. That's good. 5, we'll cross out 5. Negative 4, we'll cross out negative 4. Okay, 28 times 5. Good. That gives us 140. Divide by 4 gives us 35. Okay, perfect. And then add 1, add 1. All right, there we go. All the steps required to complete that last example problem there. Okay, again, if you guys have questions, email or ask in a Zoom, and you guys should be good. All right, we'll see you in the next video.